Hello, I'm Dan Olds, the HPC analyst for the Register, and this is yet another Register HPC channel webcast. The biggest difference between the SC shows and the other industry events is the emphasis that SC places on science and user education. At SC, it's really incredible. You can find deep, meaty content from the latest scientific findings in particular fields to a wide range of hands-on tutorial sessions that help users apply cutting-edge HPC to their toughest computing problems. Now today we're going to be taking a closer look at the technical program of SC11, which will be happening in Seattle later on this month. And we're going to hear it straight from the horse's mouth, so to speak. Our guests today are the co-chairs of the technical program, Jim Costa and Bill Kramer. Jim is the senior manager at Sandia National Laboratory, and Bill is with the NCSA, director of Blue Waters, the Blue Waters Project. And I guess the first thing I would say, guys, in bringing you in is it's really too bad that neither of you have taken the time to become involved in the SC process.
It's very difficult to become uninvolved, let's put it that way. I think as you notice, as Bill having been a previous general chair and my participation and his, there's quite a bit of experience there. But Bill in particular, and I'll put it that Bill has really been involved. And some of us just kind of tag along.
It actually that was Jim speaking right there, and I had to. That's okay. I had to. I didn't have enough room on the slide to list out all the things that you had done, and Bill, in addition to what's there, had at least 16 other SC roles dating back to 1994. Say hi, Bill.
Hi, everybody. Nice to talk to you. And the reason I think many of us are so involved is there's actually a lot of fun helping craft the entire conference and present all the different information and venues to the HPC community. So it's a lot of work, but also a lot of fun.
And we're going to take a look on this next slide here. This is the range of the technical program this year, from the typical, what you'd see at any show with keynote speakers and things like that. But why don't you guys walk us through some of these other items that we have on the slide?
So the conference consists of many aspects of the technical program. The conference originated in 1988 as a strictly technical conference, a research conference with technical papers and presentations, and then over the last couple of decades has evolved to its many-faceted role in many areas, education as well as community building and showcasing the latest technology. The conference has a couple new activities. I'll address the state of the practice briefly, and Jim, I think you should address the visualization showcase, and we can talk about a few of the other areas. The tech papers are phenomenally high-quality papers. We'll talk a little bit more of that in a minute. The state of the practice is a new feature, and it's intended to make sure that there is a place in the conference for dialogue and sharing the best practices, the things that actually make these large systems and high-performance storage and computational systems work. So it's intended not as a research, but as sharing in a formal way with reports and presentations, what people have developed in terms of how to make things more efficient, how to get more science out of the machines, as well as also what are the best practices for addressing individual specific areas. And it's gotten a tremendous response from the community, being the first time we've done something like this, and we expect it to be a really major showcase for things that the conference didn't previously focus on.
I think that makes a lot of sense, and that is something that I don't recall seeing before. I think that's going to really help out a lot of folks. What's the scientific visualization showcase?
So this is Jim. One of the things that was very clear is that there are conferences that are specializing in visualization and sister conferences to SC that we work with closely and know people. But this issue of how do we take the top high-performing computers and come up with a data transformation that is so big, so large, that you really need a visualization to really start understanding it. Well, as we start getting an SC, start getting more computational scientists along in specific domains along with the computer science and this interaction, it was very frustrating at times to people to put up very static pictures and saying, you know, here's an image of this and here's an image of that. We really decided that we needed to go to actual the ability to actually see a visualization, an evolving process, something that we can, you know, show a film clip basically of of the scientific level. So it's, again, it's what we can do off the high-performance computers, what we can do in applying it into domain space. It's not just a question of what the technologies we use, but how do we use those technologies to really answer hard scientific and engineering problems. So again, this is our first shot at it. We've got 16 presentations, and they'll be running continuous throughout the conference.
Okay, that'll be on the show floor?
Actually, it will be upstairs on the 6th floor.
Okay.
In 2 of the corridors leading into the showcase.
Okay, good. Good. And that's
leading into the exhibit area, yeah.
okay.
One last
Sure.
comment I would add that's not an explicit item stream, but is been the focus of the technical program this year is the focus on sustained performance. So the conference is trying to craft a dialogue, and it won't be the only year it happens, but it's necessary. It's important to make it explicit. And the dialogue is about the fact that there's a lot of hype and a lot of information that talks only about theoretical performance or peak performance. And
the LINPACK drag race, then, essentially.
Right.
Okay.
And what is most important, particularly for the science teams that use the systems, is how much useful work can come out of these systems in a given time period. So we've gone out of our way to try to get that focus throughout the entire technical program in some way or the other. And while sustained performance may mean different things to different people, we all kind of know it when we see it, and we know it when we are trying to be led in a different direction. So I think it will be a very interesting dialogue that will take place and hopefully be informative for the future.
Will there be some discussion on what is sustained performance and how to measure it?
Yes. So there's several of the reports and I think several papers that are dealing specifically about that. And how do you really measure sustained performance, since it means so many different things in so many different places. But there are some papers and reports that are talking about specific measures that actually would allow cross-disciplinary discussions about what sustained means across different science domains, and still comes up with a way to relatively simply compare the potential for performance across one type of system versus another, and have a real honest dialogue about what makes a difference to the science teams.
Okay. And a lot of this content's going to be available online too, right?
Yeah, do you want to talk about that, both some of the new things we're doing, Jim, about
Sure.
before and after?
So a lot of this, well, let me start off with we collect all the technical papers. They go into the ACM and the IEEE digital libraries. And that's available for free online during the week of the conference. But more importantly was, along with the technical papers and the reports that people are putting in, there was a lot of richness in the presentations, the latest breaking news people are bringing in the workshops and everything else. So this year we've gone to actually a compendium proceedings. So again, it's a little different. We will still have the technical papers. People will still have that. But we will also have more information that we used to just put off to the side and really never collect it. So we really want to get the full spectrum from discussions, from panels, things that we didn't have it. So some of it will be online that week, and later on will be in the IEEE and the ACM digital libraries.
Excellent.
So we're trying to save everything that we can so that all the information that we've brought together for this 1 week will actually stay with us and be accessible for folks later down after the conference is over, and for people who couldn't make it to Seattle.
That's great, and we have some links to those coming up for people that are listening. So you'll see some links that will take you to that stuff. Heading to the next slide, and this is something that came out of our pre-call, but that this entire SC conference really grew up around the concept of technical papers.
Yes, it did.
You could say more on that.
Okay. So we have maintained our focus on the highest quality, peer-reviewed technical content. Different types of things may have different levels of acceptance rates, but in academic and research areas, acceptance rates that range around 20% of what is submitted is found to be highly acceptable for people's careers, the quality of the papers, the fact that other people will rely on that as having been vetted and used for future research. So we target acceptance rates about that level for the technical papers.
And you said the number of papers is up significantly this year.
Yes, it's up by about almost 100, and therefore we are having about 20 more sessions than we've had in traditional years. The number of submissions has increased across the board, showing, I think, that there's a strong set of technical activities of high quality that are going on within the community, and then obviously that there's a lot of interest in high-performance computing, data storage, and analytics, which is the ranges the conference covers across all of its submissions. So the numbers are up, and we've accommodated that. We wanted to keep the acceptance rate around 20, so therefore we have some extra sessions, which is great for the attendees because they get to see more things and have that as a reference for their future work.
And I know. Go ahead.
This is Jim. I'd like to add one thing, as Bill's talked about the growth in tech papers. We've also seen that growth in other areas of the technical program.
Mm-hmm.
There are posters. We've gone up in the number of posters for availability. Again, as people were submitting more into tech papers, they've also submitted more for posters. So again, high-quality reviewed posters are up this year. We were lucky to have that. We've also expanded tutorials and workshops, and the number of workshops we're holding and the number of tutorials. Traditionally, they were Friday. I'm losing it. Traditionally, they were Sunday and Monday, were workshops and tutorials, but there had been an interest in moving the number up. We've actually now moved to the last Friday, I think the 18th. There'll be workshops and tutorials there. And the idea was to get a greater breadth. So we, as a technical program and a conference, we have very high-level workshops and tutorials, but we also realized that there is a bridge from where the education program is of starting in high-performance computing to how do you get people who are already working there and get them to the next level. So again, this idea of bringing tutorials that are lower level from cutting edge, but still very high quality, high technology type of tutorials. So again, that meant another expansion.
And speaking of people that are just getting into HPC, one of the events that I've been watching the last couple of years and will be pretty closely attuned to this year is that student cluster competition. And the number of entries, that started in 2007, and I think that they only had 4 or 5 entries then, and now they've had 17 submissions, and they'll have 8 teams there. And I've really liked watching that event take off.
So that's actually a great challenge from when the students kick off and start assembling and doing their operations on site. It's also a great time for anyone who's there to actually go talk to them. While they're very busy, they're always willing to have a conversation and tell you what they're doing. And the other thing I should notice is while it's a competition, there's great camaraderie among all the students. And we've seen it where one team can't find something and you find the guys in the next team saying, here, use this.
Last year, a team didn't have their hardware delivered. Somebody delivered a workstation instead of the cluster, and a couple of teams, one in particular, went out and helped them scavenge up systems and gave them some of their spares. It was really great to see. And just a great bunch of kids. It's really one of the, in my mind, it's one of the better events of SC. Good stuff. Flipping over to the next slide, this is the premier international show in computing these days. And it's incredible what you've put together in terms of international participation and the amount of educational material that's presented. Can we talk just a little bit more about that sustained performance that is the theme this year? Why sustained performance?
Well, so the community is moving into thinking about computer systems by the end of the decade of between 100 and 1,000 times faster than we have today. But one of the issues as those designs are being discussed and co-design activities are taking place is that it's not the peak performance that makes a difference if it's an exaflop or 100 petaflops or something, but it's really how does that technology help further science, engineering, other types of activities that all contribute to the national and global competitiveness. And the way that really happens is people want to do a certain problem size, certain challenge of understanding, and the timeliness of the result is the most important characteristic. So if machines don't help you do things faster or do new things in the same amount of time, then they're really not productive. They're not achieving their goal, even if you are able to have it run theoretically faster or differently. The other thing is if it's very hard to use, that also drives down the usefulness and sustained activities. If you have to do a lot of work that's not directly necessary to solving your problem, then the time to getting that answer is longer, or there's more effort involved. So as we go into the next decade of designing systems and talking about trade-offs, we wanted to set the bar at making that conversation about the real issue, which is getting machines that help do work or solve problems better in a more timely way or bigger problems faster, and not just for a small subset of selected applications that are demonstrations or kernels or simple tests that no longer really reflect what is being done in the science and engineering modeling communities.
So not just from a benchmark standpoint, then.
Focused on solving the real problems, not on some theoretical max or some unachievable
or a synthetic benchmark.
Synthetic benchmarks like LIMPAC and others have over time become far less useful in showing how useful or far less predictive in showing how useful a system will be there, because many of the scientific algorithms have moved from the simple algorithms that were envisioned, with say LIMPAC, to other things like sparse matrices, tree following and graph following, unstructured grids. None of those are represented in the simplified metrics that we now use that everybody hypes. So we're trying to change the dialogue and change it at this time so that it is used in co-design and exascale discussions, things like that. And the other thing is we don't want the dialogue to be limit to science areas as much as it may be by cherry-picking only the things that work well in extreme architectures.
I think that makes a lot of sense. It's going to have to be a multi-year effort in order to change the focus, though.
Yeah, exactly.
I'd like to say that one of the concepts we use in putting together a tech program is not just you do it this year, you talk about it, thanks, you're done, what are we going to do next year? But it probably falls back into what SC's overall mission is really creating that technical, interactive meeting space so you can get everyone together at one place and really talk that out and have that dialogue continue on site, during the rest of the year and next year. So you're really bringing people who, are designing the cutting edge of computing and networks and storage. You're getting the people who are going to be the ultimate users. You're getting interested parties from all over, and you're bringing them into one place. So things like State of the Practice brings in a different viewpoint that was missing at times. It still keeps the technical edge of the conference, but it makes it, what are we really going to do with these machines going down the line? And again, it's this concept of, it's the community, so you don't, sometimes we have a real blending, which is really nice, between what's an exhibitor and on the exhibit floor and what they're doing, because those people also come into the tech program and vice versa. So you see that blending, which is really kind of bringing a critical mass or a criticality that's not always found at a pure technical conference versus a pure trade show.
Well, and you're also, the vendors are bringing in their top technical people as well, not to sell but to learn.
Well, I wouldn't, we don't even differentiate, because the technical attendees are coming from all over. They're not just coming from labs and academics. They are a part of they are industrial folks. They're users. They're builders. So again, everyone's switching hats more than once during the week. But having those all in one place and having the depth to ask real hard questions is really one of the advantages and one of the really great things going on.
And a lot comes out when you have more than 5,000 program attendees involved in this. A lot of conversations and a lot of good comes out of that.
And to be honest, there's if we go to the exhibit floor, there are a lot of people who have great ideas from the tech side who say, you know what, everyone's here, everyone's got the equipment, want to run the experiment. So don't forget that there are real experiments being run at the conference.
That's a good point. Well, flipping to this next slide, so what are the must-sees here? We've got Jensen from NVIDIA's the keynote speaker. That'll be good. What are the masterworks?
Go
ahead, Jim.
There are a variety. I'd say people really need to go to the website and look. These are people who are experts who have long-standing a history of working in this world, and particularly a lot of users, the people who are using community. So you're going to see things on transportation, from hypersonic to vehicle to energy programs. You're going to see someone from the IBM Watson team. You're going to see folks on the biological team and next generation computing, quantum. So again, it's a real breadth of folks who are using it, who organizations that have really succeeded in it, and it's a little different viewpoint. It's really where we stand today type of views, what we're doing, where we're going in the future, versus a very specific technical. So it gives you that greater breadth.
So
again,
the context.
Masterworks. Yeah, I should go back to the wording. It's the masters, what they've done and where they're going.
And we talked about the visualizations showcase and the papers, and the doctoral showcase. That's different from, what is the doctoral showcase? Let me just ask that.
So the doctoral showcase is an opportunity for selected, peer-reviewed doctoral candidates that have almost finished their research to have a short session, 20 minutes, to showcase their achievements. So it's a way of introducing new technologists to the community, certainly new ideas. They're not full-fledged papers, but they are selected as leading edge new research and new people, and it's a good way to introduce new people to the community and maybe also help make matches for professional jobs, careers, or collaborations.
Excellent. I need to stop by that this year. I haven't looked in on that before.
We also have, as part of our awards activity, several awards. There's 3 major awards given by societies the Kennedy Award, the Gordon Bell Awards, Seymour Cray Award, and the Fernbach Award. So I guess that's 4 actually. And then the conference has established a fellowship for, again, graduate students who are working in the realm of high-performance computing, data and networking and analytics. And every year we announce the winners at the award ceremony, but we also invite the previous year's winners back to present their results and their progress in a formal presentation. That's the George Michael Memorial HPC Fellowship session that is on Thursday morning.
Good. Okay. And this last slide here, for more information, here are the links that people can use to see the content, get a glimpse at what they'll see if they go to Seattle, or if they can't go to Seattle, to take a look at what's happened up there. This is going to be quite a show, and I think that from what I'm hearing, it's already beating attendance estimates from previous years. Is that true?
The numbers are up. I just looked
yeah.
this morning, and the numbers are up ahead of the trends from previous years. We're having countries, attendees from countries that we've never attended before. This is a global community that's coming, so it's been very exciting to watch.
But there's still room. There's still room for more. So if you want to, everybody listening out there, if you have a chance, any chance at all, to get to Seattle, this is the premier show in the industry. And even if you're not involved in HPC computing, what happens in HPC is going to be coming down into enterprise and even personal computing. This is the Formula One racing of our industry, and one of the premier events of the year. And I guess in closing, I just want to thank you both, Bill and Jim, for taking the time to talk to us about this, and really appreciate that. And we will see you at the show.
Great. Well, thank you for spending time with us.
And let me add my thanks. You're talking to Bill and I today, but even in tech programs, there's a team of well over 150 people who put this together, from reviewing to putting individual talks together, to put sessions together, committee chairs. It's been quite an experience. And the last is, I need to thank Bill, because one of the things you should know is that Bill's a Yankees fan and I'm a Red Sox, and it was a tough season going through the summer, but we pulled it together, and both of us are, I've got over our crying, and so we're really excited about coming up to Seattle in a couple weeks.
Well, that's good that you can bury the hatchet. It gives us kind of a poignant ending to this webcast, but nice to hear. And but then again, we'll have the competition again with the student cluster competition. I'm trying to build sort of a college football-like air around that. We'll see how that goes. But I'm really looking forward to the show and to meeting both of you when I'm up there. So thanks again.
Thank you.
And thank you, everybody, for listening.
Thanks a lot.